to show you the process and then to okay, we have a few more to look at. They are the power ones. So we have some more indeterminate forms, 1 to the infinity, 0 to the 0, and infinity to the 0. All three of those are in indeterminate forms and are going to need a special process in order to evaluate their limits. Okay, so here's an example of one. If I take the limit as x approaches infinity of x to the 1 over x. Now if I stick infinity into x, the function x will get large. It will head to infinity. And if I plug infinity to the exponent, that exponent's going to get very close to 0. So I have infinity to the 0 power, which is going to use L'Hopital's rule. However, we're going to have to use logarithms on this because logarithms are how we get rid of exponents. So the long way of doing this is to write this as an equation, y equals the limit of our function. And then I'm going to take the natural log on both sides of the equation. So that's all I did here. I took the natural log here and I took the natural log here. And now I'm just going to rearrange some stuff. I want the limit on the outside and the natural log right next to my function. So it is okay to interchange these. Next step, we are going to do the log rules. I'm sorry. We are going to apply the log rules to the right side here. So the log rules tell me that I can bring an exponent down in front and multiply it, which is what I did right here. And then after that, we are going to just rewrite it so that I have a function over a function. So instead of writing it right here as 1 over x times the natural log of x, I'm writing it as the natural log of x over x. If I plug infinity into this, the natural log of infinity is infinity, and then if I plug infinity into x, that's infinity. So now I get this L'Hopital's indeterminate form. So now I can do the derivative process. So if I take the derivative of this function, I'm going to get 1 over x. The derivative of x is 1. Or I just get the natural log of y equals 0 over 1, which is 0. Well, that's all great and everything, but the natural log of y equals 0. I need to know what y equals. So now to get y alone, I'm going to raise both sides to e because we want to get y alone. So if I raise this to the e and this side to the e, I'm going to get y equals 1, which is going to be the limit of this function. Okay, so here is another way of doing the same process that I just did. What I just showed you was step by step by step way of doing a limit like that. Here is a kind of an abbreviated way, so you can kind of choose which way makes more sense to you. But when you're evaluating these types of indeterminate forms, what we end up doing is taking the natural log of it, bringing the exponent down in front, and then many times then we multiply it. Now, I need this to be in a fraction form. So instead of n times the natural log of u, I can write that as the natural log of u divided by 1 over n. Because if I flipped and multiplied this, it would end up exactly like this part right here. But what this does is just gets me into a function divided by a function, which is what we need for L'Hopital's rule. And then what we do is, to make it a little bit shorter, what they did was they raised it to the e power and natural logged it all in one step. Because if you take the natural log of something and then raise it to the e, they undo each other. And so then you can just evaluate it all at the exact same time. And I'll show you how they did that in the next slide. So here is that exact same problem that I did the long way, or actually the step-by-step way, and here's the other way of doing it. So we start off with the same function, and it's infinity to the 0. And what they did is they raised it to the natural log and to the e simultaneously because they undo each other, and went through and used the log rules to pull down the 1 over x, then wrote it as a fraction, took a derivative, and evaluated. So you can either do a natural log on both sides and then at the end raise both sides to the e, or you can, right here, take the natural log and the e at the same time. Whatever you think is easier. Have you practiced